Streaming. I'm always scared whenever I do this. I always feel like it's gonna blow up in my face.
Who's going to be sharing their screen first? Is that going to be Chris with the 2 encoding problems?
Sure.
All right, and then Chris, you've already made the Pico CTF account, right? And you know where the gym is.
No.
Just go to the link in the Q&A channel and just sign up for that real fast. Because that actually shows you what the challenges are, not what the solutions are.
Oh, okay.
Yeah, the links in the Google Doc we have are the solution guides.
Yeah, no, I see it.
And just like that, we are.
You can tell that we're really well prepared for this, right?
Every single
Go after
time,
as well.
it's exactly like this.
Again, I have another homework due tonight, so I have to present and then get going again.
All right, streaming. So who's starting?
Oh, cool. On a similar note, though, before we get started, all of these challenges that we'll be showing you do have solutions that are publicly available. So if you're following along tonight and you can't quite catch up, think you missed something, Google is your friend. They're online.
We'll share the link to the solutions afterwards.
Yeah. Okay, so I just need to go find Let's Warm Up.
All right.
And then
also, I need to go and
Bases
find the stream
is
link.
the next one. Okay, I'll find that one later. Okay, then let me...
There's a little search bar.
Yep, I know.
All right. There's the YouTube link, and we're going to post it here too. So then we can click watch stream. Chris, your stream is up.
Mm-hmm.
Can you zoom in a couple times? Control Shift plus, I think.
Oops. What the?
It's Control Shift plus to zoom in, and then Control minus.
I got it. I was just wondering why the equal signs were like getting bigger, sort of. Is that better?
Maybe 1 or 2 more times. Perfect.
Okay.
RJ's microphone is fluctuating wildly on my end. Like sometimes it's real quiet, and then other times it's real loud.
Okay,
I assume he's just getting closer.
Yeah. Are enough people watching that I can just go ahead? I can't really see the... Can I? 12 people. Good enough.
Yep.
Okay. First one. The description is, if I told you a word started with X70 in hexadecimal, what would it start with?
Can you show before we start with the challenges, can you just show what the website looks like and how to navigate it? How to find the challenges and such?
Sure.
Why did I have the Safari logo and then take you to Firefox?
Oh, it's local only internet from last time. This is why.
All right, do you want me to just pull it up?
Yeah.
Right,
yeah.
I will share instead. Yeah, because you'll have to revert that VM or like screw with the network settings. All right.
All right, so you're just going to show these?
All
first
right. Let's see RJ's stream. Wait for that. What? Oop, I clicked on Nicola. Oops. How do I go back? Okay. RJ's stream. It's loading. It's loading. Please don't do this again.
You're not streaming to YouTube, are you?
This is going to YouTube.
Okay. Even if it is, I don't care. I'm just going to keep going even if it's loading for you. So, right?
Oh,
we're just going to do it. Because last time it was just a lot of waiting. All right. So, I believe it was let's warm up first, right?
Yes.
So we have this little pop-up. It says, if I told you a word started with 0x70 in hexadecimal, what would it start with in ASCII? So for those of you who don't know, ASCII is an encoding used for printable characters. I forget what the acronym stands for, but it's basically this big conversion chart between a number and what it's represented as a character. So if we just Google ASCII table, there's a bunch of images that have like all the different conversions. Here's one. So like, for example, it has like the space character is 20 in hexadecimal and 32 in decimal. The capital A character is 65 or 41 in hex, and they kind of start them at helpful positions. Like A starts at 41 for capital A in hex, and then at 61 for lowercase a in hex, and 21, or I guess 20 for like some of the different characters and decimal numbers. In any case, it's basically a way to convert from a number to a letter that you can see.
Also, ASCII stands for American Standard Code for Information Interchange. Thank you very much.
Thank you. I didn't know that.
You don't need to.
So basically for this, it's asking us to convert hex 70 into ASCII. So we could just look it up in the ASCII table, and the answer to that would be, this is the hexadecimal column right here, 70 is a lowercase p. But you could also convert it like manually by hand. I guess doing like hexadecimal to decimal to ASCII or something. But I would just Google it and look it up in this table, or use something like Python and convert it that way. But are there any questions about that one?
I have decided to just do my own stream and pretend to follow along.
Right. So for this one, I just Googled the ASCII table. Python's probably the better way to do it because
you can also Google an ASCII converter.
That is true. Oh yeah, they have
just bam, it's the letter P.
Yeah. So
wait, hold on.
This is ASCII to text.
Oh, wait, hold on.
Oh god, something's happening. Please mute him. Alright. Fuck.
That's really loud, Craig.
You are on stream. You just blew out the YouTuber's ears. Please, for the love of God. And I sweared because of it. This is not okay.
Sorry, Craig, that was really loud. I think your microphone's really loud or something.
You need to mute yourself, please. It's still going. Okay, thank you.
If you can look at your microphone settings, that would be really helpful. But then for now, just ask in chat.
It's okay, cool. So one thing to note here, right? So we did the translation, right? And I just tried to type in P and it said, no, you're wrong. But if you notice right here, it says Pico CTF and then in curly braces, the flag. That is something you'll see a lot. Generally speaking, when you encounter a CTF, you'll find these Pico CTFs. And I actually apparently
have a
need
flag
to zoom
format,
in.
so it shows it here. So I'm still streaming, right?
No,
Yeah.
I'm watching my own stream because your thing didn't work.
Wait. Oh, are people not?
I'm watching the thing from my own account. Anyway, so this Pico CTF. So what I need to do, since I got the flag, I need to put this P in curly braces and then type in Pico CTF, and then if I do that, it should work.
Richard, what are you doing?
I have decided, since RJ's thing didn't work, and so the YouTube audience, the people who watch this later, can actually see what's going on, to just do it on mine and try to follow along.
Richard, so we have half the people watching me and half watching you. We've got to only stream one at a time. And since I'll be doing like the majority of the demos for this, I think it.
Yeah, well, I mean, you decided it wasn't working on the YouTube end, so I'm just trying to make it do something for them.
Okay.
Then don't present.
Yeah.
I need to present to be able to show it to YouTube. That's how
we
this
shouldn't.
works.
Okay, then we shouldn't be streaming to YouTube. Then we should just put it on here.
Okay, cool. Well, if anyone has any complaints about not having it on YouTube, you know who to talk to.
You can have.
Okay.
You can stream yours and like follow along, but don't like.
That was what I was
over.
doing.
Yeah, but then you like took. I'm an alumni.
Just keep going, RJ.
All right. So we'll be doing it on my stream. So if you notice, again, there's the tool for converting hexadecimal to ASCII. I just Googled it. You can do that online. You can just look up an ASCII table. But often there will be like larger amounts of text you have to convert all at once from hex to ASCII, so it's better to use the online tools. And as Richard said, there's typically a flag format at the CTFs, so they'll ask you to submit, like, it'll be like the name of the CTF and then like a curly brace and then whatever the flag is and then another curly brace. So in this case, our answer was P, so we just do Pico CTF curly brace P, like it asks us to format it, and then hit submit flag. And we got the flag, which was worth 50 points. So that's the first one. What was the next one, Chris?
It is bases.
Okay, so I'm going to search for bases.
Also, Richard, just for having it, I opened up OBS and I'm just recording RJ's stream because it's loaded on my end. So if the YouTube stream doesn't work, we can always just upload my recording.
Okay. Thanks, Chris. So for this one, the description of the challenge is, so first of all, the name of the challenge is often a hint towards what you need to do. So the hint is bases, or I guess the challenge name is bases. And then the description of the challenge says, what does this? And they give us this long string of characters, starting with a B. They say, what does that mean? And they say, I think it has something to do with bases. So for this one, it's kind of something you have to see before, but this is encoded in what we call base 64 encoding. So base 64 is a way to represent data as all printable characters. It allows you to basically convert bytes that may or may not be printable into a printable format. And everything is encoded into 6-bit characters, meaning, so 2 to the 6 is 64, which is why you'd call it base 64. And it's basically, everything is represented by either a lowercase a through z, uppercase a through z, 0 to 9, and then there's a plus and slash rounding out the last 2 characters of the 64 total. And you'll also see equal signs at the end sometimes for like padding purposes. So if you see like a big string of like all upper lowercase character numbers and like sometimes like a plus slash and then equals at the end, maybe, it's likely base 64. And you can again just Google a decoder for this.
One thing to note about the equals padding, it doesn't actually need to round it out. You can just fill it up with as many equal signs as you want, and it doesn't change anything. Just something interesting to note.
Yep. So thank you, Richard. So that was Googled. I just Googled base 64 decode and plugged into this decoder online, and it says that the answer is this string that says, I guess it's like leet speak for learn the ropes. So I'm going to copy that, and I'm going to put it back into the flag format. So it wants to submit with the Pico CTF flag format. Like this, and I'm going to submit the flag. And we got 100 points. So are there any questions about that one before I move on? I'm going to go to the Q&A channel really fast. Okay, you'll see base 64 encoding a lot, so it's good to know what that is and kind of how to spot it. We're going to do a little bit more like encoding and crypto stuff coming on. So the next one is called 13. So I'm going to search for that here. All right, so we have another 100-point question. The title is named 13. And then the description says, cryptography can be easy. Do you know what ROT13 is? And then they give us this string that seems like it's an encoded flag. You'll notice, so the flag format is Pico CTF, where the CTF is capital, and we have like 3 capital characters here and 4 lowercase here. And we have some curly braces. So it looks like this is the flag format, just encoded somehow. And ROT13 is basically the Caesar cipher, where you shift it 13 characters, and if you shift another 13, it'll go back to the original. So it's basically Caesar cipher where the encryption and decryption is the same. You'll see ROT13 a lot, or you can just look for like a Caesar cipher brute forcer. So I'll show you both ways. There's a really handy tool. What's it called again? What's the GCHQ like crypto tool called again? I always forget its name.
CyberChef.
CyberChef, thank you. Yep. So this is like one of my best friends for CTF challenges that have to do with crypto. They've got base64 encoding. They've got like hexadecimal, ASCII. So like all the other things that I was showing on the other websites, you can use on this one. They have one just called Magic, which will just try to figure out how it's encoded for you. I haven't really gotten to work much, but like it's worked 1 or 2 times. But if we search ROT13 and plug it over into the recipe section, we paste our input here. It applies this recipe, which could be 1 or more things, and it gives us an output. And the output says Pico CTF, not too bad of a problem, and that's our flag. I'm going to copy that. Another thing you can do is just try like brute forcing the Caesar cipher. Actually, I guess they don't have the brute force here, but brute force Caesar cipher. And remember, you'll do a lot of Googling during CTFs. If you're not sure about something, just Google it. Decode.fr is another site I use a lot. Whoops, I want the encoded version. So we'll paste the encoded version here, and it'll try all the possible shifts, just in case it's not ROT13, and it'll try to rank them based on character frequency. And you can see that the correct one was put at the top, but it shows you all of the possible Caesar cipher decodings, and that's kind of handy in case it's not ROT13, but some other like shift cipher. So the answer was this flag. So we're going to paste it in and get points. Right. I'll do Visionaire, and then I'll hand it over to Anna before getting to some of the harder crypto problems. So what was that one called? It was Easy 1. So Easy 1, it doesn't look like the title's much of a hint here. And the description is, the one-time pad can be cryptographically secure, but not when you know the key. Can you solve this? Oh, actually, it's not Visionaire, it's one-time pad. Okay. We've given you the encrypted flag, key, and a table to help. So we have this string right here, which is the encoded flag, and we have a key, which is the word solve crypto, and then they link us to this table. So one-time pad is basically, I'll open it. One-time, oh goodness. I actually thought this was a different challenge. I thought this was a Visionaire one, so I might have looked it up wrong. Actually, how about I hand it off to Anna, and we'll come back to this one, because I thought it was a different one.
Can I do mine real quick before that? Because I got to get going.
Oh, sure. Yeah. Joe, you can go,
Cool.
and then Anna, and then I'll go later.
All right.
Okay, I will stop streaming.
Okay, so if you tune into my stream, you can see the file here. This was a challenge that we had during the Dawg CTF. Forget what year, either last year or the one before. And I don't have the challenge description or the title for it, but this is, it probably wasn't super descript. It's pretty much what you got. So you can see on each line, you just have 2 values kind of separated by a colon, and you got to kind of figure out what you want to do to solve the challenge. So if we just Google like, what is NPLM? So we go into Google. What was that?
Can anyone else see the stream? Mine's not
Oh, is
loading.
it not loading? Okay, hang on.
Well, I don't know if other people could see it.
Couldn't.
Now it's good. Okay.
All right. This is just streaming a window. So I won't be able to show.
Would you
I guess
zoom
I'll
in a
switch
bit
over
if you
later.
can?
Yeah. So you have a file that looks like this, and if you're familiar with hashing, you probably would recognize some of these, but if you're not, Google's always your friend for solving challenges like these. So if I Google maybe NTLM, and I can't really show this without restreaming, but if, let's see. Google already tries to add the word hash after it, so that might give you a hint. Maybe I'll Google like MD5, and that kind of gives you thing telling you that it's hash. And if you're familiar with a hash, basically it will take a piece of data, and it could be of any length really, and it'll turn into it's like a one-way function. It will turn into a almost unique string of text. And I say almost because there are times where where two different pieces of text can become the same hash, and that's why I have certain bigger hashes, generally speaking, to reduce the chance of what's called a collision. So, as I said, it's a one-way function, so you can't really tell what any of these hashes were previously, but you can do like a brute force kind of check where you maybe check like the letter A and then see if that's the hash, check the letter B, and you keep going and expand the input. It's fairly inefficient. And each of these are all different hashing algorithms here, and they have various runtimes. So like SHA-512, I'm pretty sure is going to take a lot longer than any of these. And MD2, MD4, MD5 have plenty of collisions actually. So and I think SHA-1 actually. So these are all now unsafe because you can easily create a collision, which can be problematic because sometimes these hashes are used for like checking a firmware update or something like that to make
Or
sure it's a
storing
legitimate
passwords.
one. Yeah, or storing passwords. So these aren't used anymore. Usually you now see like SHA-256, SHA-512. Some of these other ones have limited use cases. Windows uses NTLM. I'm not sure if they still do or not, but at least at some point they did.
I think they still do. LM, which is the LAN manager hash, which is the precursor to NTLM, is the least safe of any of those hashes. It's actually really easy to reverse.
Yeah.
But
not reverse though, to brute force because it's right because it's going to
yeah,
be
brute
extraordinarily
force.
fast to brute force it.
It was also some of the like password requirements for Windows that made it specifically easy, but it's not a good hash.
Yep. So I'm going to switch to sharing my browser to show how to solve the challenge. So there are some sites, they won't brute force these hashes for you, but they'll kind of have a lookup table for maybe the first 10 or so characters for each hash or something like that. Basically, they have a database of this character corresponds to this hash, and when you submit a hash, it will do a lookup. So if we input all of these hashes on this site without the initial part, so just the second part, see there's no like LM or NTLM here anymore, this site will actually go and check for you. And when you run that, you get a result. I guess LM can be uppercase or lowercase there. But you see the output Dawg CTF, that's our flag format. And then I'm not sure if that's supposed to be something there or if that's just random text. But
Yeah,
you
that's
put that
right.
all together. Yeah. I'm not sure if it was like a
It was
leak
random.
speak or something. Okay. And that's how you'd get the flag with this challenge. For longer hashes, you'd probably have to run your own. Oh, like if it was a password cracking challenge, you'd probably have to run your own uh, password cracking tool, like Hashcat or John the Ripper. And those can take tons of computing power and a lot of time. So sometimes you need to narrow it down with like a password list or some kind of custom dictionary. So some challenges I've seen, it'll be like the password is some combination of like attributes about our club or something like that. Like I don't really like those challenges because they're too specific. But if you have enough like GPU power or computing power, you can brute force most hashes. But passwords kind of beyond the length of like 10 or so become very, very difficult to do if you're just straight up brute forcing, like checking every possible combination. So uh, I'm pretty sure the class will go over that more later. So you'll see more then. Anyone have anything to add to that? That's all I have for this challenge.
No, that was a good description. Thank you.
So just if you're not sure, Google things and try and figure out what's going on. You can spend a little bit of time Googling things to figure out potentially how to solve the challenge. And some of these are also integrated inside of challenges, like the Base64 one that RJ showed. That's often not its own challenge. Often you'll see that as part of another challenge. So it's good to be able to recognize things like these.
Cool. My turn, question mark. Great. So, going. So I'm gonna talk a little bit first about coding challenges. These are some of my favorites. I think they're fun. So the first one we're gonna go over, I hope you can see this. It's called Based. It's kind of a general coding challenge that you probably didn't necessarily need to program for. That honestly might be over engineering for this challenge, but it's still fun. So essentially, the description says to get truly leet, you must understand different data encodings such as hexadecimal or binary. Can you get the flag from this program to prove you're on the way to becoming leet? And then it gives you a netcat command. And this you're going to see a lot in coding challenges and also binary exploitation, which we'll talk about after this. So netcat's a program that you probably maybe touched on in some of the Linux meetings. Is this a good size?
Maybe a bit larger. Control-Shift+.
RJ cannot see anything.
I'm blind, okay?
Okay.
I'm farsighted.
Also, you know it's not actually Control-Shift+, it's just Control+, but you need the Shift key because it's otherwise an equal sign. That's just how plus works.
I know, but it doesn't make sense to me.
Cool. So, the first thing I always do whenever I get a netcat command in a challenge is I always run it. It's a good way to see, number one, is the challenge working? Number two, just kind of what you're getting into. So let's see how this data is stored. Random word falcon, and then some data in binary. I know this is binary just looking at it because it is all zeros and ones, binary encoding. I actually figured out when I was looking at this earlier that they screwed up this challenge and you actually get the first word for free. So they just kind of accidentally printed you the answer to the first one, which is kind of funny, honestly. It happens to all of us as challenge authors. But essentially, if you were to take this and decode it into text ASCII, you would get the word falcon. It worked. And then it has the second one, which is octal. You know this because all the characters are between 1 and 8, and it's also a 3-digit number. 3-digit number almost always means octal. Rarely do you see it not be octal. Because I am not God, I don't know this off the top of my head. So I got too slow. You have 45 seconds, so if you are good with typing fast, you probably could do all of this by hand. But because we're better than that, we're going to do a little bit of Python code. If you don't know Python, I know some of you are probably in 201 right now learning. Try to follow along. It's not a particularly, I guess, the Python language is pretty similar to English, so a lot of the sort of code that you're going to be writing is going to look a lot like English, so hopefully you'll be able to kind of follow along. But I digress. So, sol.py, that's always what I call my solution files. Call it whatever you want. The kind of purpose behind going over this challenge in a coding method rather than just Googling things, which Google is your friend, could definitely solve this with Google, is that Pwn Tools is a super, super useful Python library that allows you to do a variety of different things that can be with coding challenges, reversing challenges I've solved with Pwn Tools, and then Pwn or binary exploitation challenges, also super common to solve with Pwn Tools. So In order to do that, I can link the Python package after I do this. You always start with from pwn import star. This is just your import with Python. There's also a another package called RE that we'll also be using. All right, so first kind of main step with pwn tools is you want to set up the process that you want to be communicating with. So in our case, we have this nice netcat command that they gave us, and you can communicate with that through pwn tools, which is pretty cool. So I'm gonna call it proc. And the way pwn tools works is you just instantiate a process. You're going to have the, oh my gosh, I'm blanking on every word in the English language here. The name as a string, and then the port number is going to be an int. So this is kind of how you're going to basic set up all of your pwn tool scripts. After this, you can just do a simple proc.interactive. So this is saying I want to interact with the process over the command line. So in order to test this, just using Python, I am an idiot. And this is a remote process. So if you wanted to interact with a normal process, like you have a binary on your system, you want to interact with that, you're going to use process. Because this is remote, it's a remote. Same idea, now it actually works. So now we have this process that we can interact with. We can put in words. It'll say that we're wrong. So now you probably want to do some sort of computation. So right now we see that we have, let us see how this data is stored. Please, we're gonna, for the purpose of this, we'll ignore that they accidentally gave us the answer. In normal life, I would definitely use that. But now we have, please give us the, and then there's this binary string, and then as a word. So in order to interact with this in pwn tools, you're going to want to use receive line, receive until, receive line, and send line. So you can say proc.receive until, and we're going to receive until the word the. And that will give us everything up to the word the, and we can print that out. After this, we can say that the word that we're trying to use is going to be until the as, and receive until also has a drop kind of option so that you can actually drop whatever you're getting. So if I set drop equal to true, sorry, I've been coding in C all day, and then I print word, we will print, that's great. Cool. Oh, there it is. Yeah. So we have please give the, and then this is what word was equal to. This was the original data that we printed out and received. This is what word was equal to. And we noticed we dropped the as. So if you don't have drop equals true, you'll get all the data. Drop lets you drop any extra characters that you don't want. So because we're trying to hone in on just this binary, we're going to drop the as. True. Cool. So now we have this word, and we know that it's in binary, and we want to convert it to ASCII. There's a million ways to skin a cat on this one. I'm going to do it pretty simply. So we can split the word up by spaces, and then that will give us, if we print I, you can see that that gives you all of the different binary components as their own kind of chunks. After this, we can kind of start to, we can start to Oh my gosh, I'm losing English here. Split the word up into characters so we can print out each character. And that just took each of the little binary chunks. It said I want to make an integer out of those, assuming that the base is 2 because it's binary, and then we casted that to a character. After this, we can go through and set it to a variable. So now we're just making a string, setting each character, like adding each character to that string, and then we can print the string. And it should give us table, which was the same word. So after this, we can do a send, which will send whatever data we have stored in this character to the server with a new line at the end, which is how you get send line. If you just want to send the data without a new line, you would just do send. But we want the new line just because that's kind of how this server's interacting. It's kind of a trial and error whether you're going to want to send a new line or not. A lot of times if you're sending binary data, you don't want the new line. In this case, we're sending ASCII, so we kind of do. So cool. That worked. We sent it the input. It won't show up here because we sent it to the server. And now it says, please give me the next thing as a word. So I could keep going with this. I'm hoping that kind of gave the general overview. RJ, do you have opinions? Should I finish this challenge, or is that like kind of a...
Unless other people want that, I think it is a really good summary of Pwn tools. Again, it's a really, really useful tool for both these coding challenges and actual like binary exploitation challenges that we definitely think is useful enough to recommend you look into.
Actually, here's the actual solution that I wrote earlier today when I wanted to make sure that I wasn't going to screw anything up. So here, the first was binary. So you received until everything and then sent that. The next one was octal. So you would do the same thing. Receive until, and then you have an octal, and you would convert it that way. The last one was a little bit trickier. I can run this. So the last one, it actually gave it to you in hexadecimal, but it didn't give you any spaces. So instead of splitting everything by the space, because we no longer had a space to split by, I ended up using RE. It's a really good reverse engineering tool. In this case, it also does find all, and that you can put in how many characters you would like to find, and it will split them up into a string. It's actually like super useful and would be a lot of weird for loops and Python if you didn't use RE. But after that, it's the same method. It's base 16 because it's hex, and then you can set that to a character. Cool. So any questions on that and Pwn tools? I know that was probably a lot. But also, if you have any questions, just feel free to DM me, shout at me. I love talking about this stuff, so definitely willing to answer anything. The next... Anything? Cool. Next challenge I'm going to be going over is actually one that I wrote a couple years ago for the CTF, Dawg CTF. It's held every spring. You all should definitely come out and play. It's a really fun time. I'm probably going to write a bunch of challenges again, unless everyone doesn't let me, but I hope they do.
We will let you write every challenge.
Okay, awesome. You owe me... I will bill you my hourly.
Oh.
For all of the crypto.
Well, we're not spending money on travel this year, so that's probably fine.
Oh, hell
We'll
yeah.
buy you a nice pack of Corona beer just for the occasion.
You know, I honestly, all right. Can I get a slightly better beer though? But I dare
Natty
Not
you.
while
Light.
coronavirus is here. Not while coronavirus is here. There's only one option right now.
So this challenge, it actually utilized one of my all-time favorite Linux commands. If you haven't heard of it, there's a command called cowsay. It's similar to echo. So if you were here in some of the other Linux lectures, we probably talked about echo. How if you echo hi, it will just print hi. Cowsay is just like echo, except way cooler because a cow says it now. You can also change the cows into a bunch of different, they have like a bunch of different cows you can use. Some of them more appropriate than others, but I think it's a fun little thing. And yeah, so this is a binary exploitation challenge, and in my opinion, they are the best challenges at every CTF. Tons of fun, but essentially binary exploitation, you're given a binary, in this case source and source.c. This binary,
What's a binary?
I was getting there. A binary is just a compiled program. So certain programming languages require you to compile the source into a binary format. If you were to cat the binary, it's going to look like garbage. It's computer language that they can understand. Okay, this looks like less garbage, but there we go. It's the computer's language. And then the source code is found. I can type today. Here. So I actually wrote this challenge a couple years ago and lost the source for it. So this is not the exact source code for the challenge. However, it is pretty good. We're not going to go too far into sort of talking about how you would reverse this source code and sort of get into the depths of C. This is all written in the C programming language. Beautiful language. There's a reason it's been around since the 70s and is still used today. And it's not just because it's on everything and they can't port it to anything else. So kind of back to the idea. So binary exploitation challenges, your goal is to get a shell on whatever system or get the flag off of whatever system you're attacking. So if I'm running my Windows machine and I say I have a file on this that you want, your goal would be to kind of, at its most rudimentary term, hack into my Windows machine and get that flag off of it. In this case, usually binary exploitation challenges require you to attack a single binary. There are ones that don't, and those are usually used in much harder CTFs than the ones we'll kind of be doing over the next couple weeks and months. So generally speaking, you'll be given a binary. In this case, you would be given the source binary and possibly the source code that goes along with it. So this is the sort of source code. And you would, again, have a netcat shell. There we go. Got it. A netcat command that would be given to you. In this case, RJ just spun this one up for me. Thanks, RJ.
Actually, all of Dawg CTF is spun up on that IP address, so if you connect to the other ports, like 4,000 to 5,000, there's stuff on them too.
That's great. Yeah, I really like running. Anyway, so cool. So back to this. The first thing I always do in pwnable challenges, much like coding challenges, is I run the binary and see what it gets me. So what does the fox say? If you saw that viral internet video from like the mid 2000s, I hope it was the mid 2000s or mid 2010s. There we go. The stupid song, "What Does the Fox Say?" That was kind of the inspiration for this challenge. A lot of my challenges are based off of stupid things like that. So we'll just put in some random text and it's not going to work. Cool. All right, there we go. I did do this ASCII fox all by myself. Please clap. So we have first it prints out this string that says your command and then user games cowsay ASDF. So that's kind of a first hint into what's going on here. After that, it prints out what appears to be what would happen if you would run the cowsay command on the target box. So that's pretty cool. And that also kind of lets us figure out how to solve it. So in this case, I probably wouldn't even look at the source code for this challenge. But if you wanted to, you can see that we are printing out what does the fox say, printing out enter text here. We're going to get that text into a buffer. And we're going to make sure that buffer doesn't have any backslashes. And then we're going to print out whatever command we ran after copying the whatever input we gave it into the command. So basically just putting in our, like, concatenating the two together, essentially. After that, we're running system on the command. System is a, oh my gosh, function that you'll see a lot of times in binary exploitation challenges. It essentially runs that command as if you had typed it into the command line. So in this case, when we input the text ASDF, it ran user games cowsay ASDF. Cool. So one of the neat things about Linux commands is that you can chain a lot of them together. So if I were to run echo hi, then I want to run ls and print out all of my directories. You can add a semicolon between the two, and you'll be able to hi, and then it printed out everything in this directory. This is pretty useful for scripting and a lot of other things, but it also makes this source code really vulnerable, because that means you can say something like user games cowsay ASDF semicolon echo hi. So let's try that. So if we did ASDF semicolon echo hi, cool. So that proved that we can execute arbitrary code or arbitrary Linux commands on this other machine. So we can also do something like ls. Okay, so now we know that there is a flag.txt along with the fox binary, which is presumably what's actually running this. After this, I would do something like cat flag.txt. And we get a flag, wapow, rengi hati, which were words in the song. It was funny at the time, I swear. So pwnable challenges can range from something like this, which are often called command injection, because you're injecting a command into another command. Like in this case, we concatenated the two commands together. But they can also get a lot more complex and a lot more of utilizing the binary, and sometimes you have to only use the code that's given to you. Sometimes it's a lot of things. Don't worry too much about that until you kind of get to the 313-ish level. That's when all of this will start making a lot more sense. Any questions on that? As long as you're still all alive and awake.
No, that was a really good demo.
Yeah. Cool.
Command injection is really fun.
Command injection is
honestly... I'm not good at other pwnable stuff, but I really like command injection.
It's a... I think it's a really great way. It was definitely the first kind of challenges I really liked with pwnables, because I think it forces you to kind of think outside the box. I actually did a command injection challenge the other week that was you couldn't use any English characters, so no A, B, C, D, E, F, G, and no integers. So you just had to use like $signs and parentheses and everything, and it's possible. Anything's possible. now we're going to talk about one of my least favorite challenges, which is web. Nothing against web. These challenges, you will often be given a website. That's what happened in this case, and I closed out the tab that I needed. I do not remember what this was called. However, it's a web exploitation challenge. Believe it was don't use client side. It might have been. I apologize if it wasn't. I'll figure it out and send it in the chat. But yeah.
It is. The other web one was change the cookie. Oh no,
Yeah.
sorry, it was actually I have no idea.
Yeah, I have no idea.
But it's just called Log On, I think.
Oh, okay. Yeah. So this one's called Don't Use the Client Side. And it says, can you break into this super secure portal? And then it gives you a link to the challenge, which is pulled up here. So web challenges, a lot of the time, in my opinion at least, and from what I've talked to other people about, also theirs, a lot of times web is going through the same maybe 10 different sort of general strategies of attacking a website, and usually not guessing, but using context clues to kind of figure out what's happening. So the first thing I usually do if I'm given a web challenge and there's a text box is I type random text into it and see what happens. That's honestly what you should do in most cases with most challenges, is kind of explore around and see what happens when you do different things and interact with it. It's kind of a terrible idea to just get a challenge and immediately start reversing it or attacking it in a different way. But yeah, you guys can see this website, right? Cool, gonna say yes. So
Yep, we can see it.
I'm not a web person. I don't know many things about web, but the first thing I know to do is always just do inspect element. This allows you to see a lot of the different source code of the website. You can also see different application features. You can mess with the cookies. You can mess with different performance. You can see the network requests. In this case, though, we're just going to go to the source code and see what's happening. So the challenge name was a bit of a hint in this case. It's called Don't Use Client Side, and it's a terrible idea if you're designing a website to use client-side authentication, because you send all of the code of your website to the client. That's how the website gets rendered. In this case, you also sent your verify function when you're verifying this password. So it's going to, I don't know HTML, but I can see that there's a check pass equals document password, which I'm going to assume is this. And then it's going to split something. All right, so split is 4. So you get a little substring, and all right, if between 0 and 4 of the substring is pico, that looks like a flag, and then keeps going down. In this case, you can run this code. You can do it a variety of different ways. I do it in Notepad because I'm kind of lazy. So between 0 and split, you have pico. Between split and split times 2, over here, CTF. No underscore C LIEN TS underscore PLZ underscore 5 6A 8E B closing parentheses. So if you had put this in, you would get a password verified alert, it looks like. So we can try that. And we get password verified, which also happens to be the flag. All right, I don't know what's happening there. So I'm going to do what I always do if I don't know what happens in a live demo and close it and move on.
Nice.
I don't know. Most of my other ones weren't inputting either. So Pico CTF is a interesting CTF in which they don't actually let you reuse flags between the two. So it's actually starting up in a couple days. I recommend all of you should play it. Even if you just look at a couple challenges, it's really fun. But essentially what they do to ensure people aren't cheating, or not ensure they aren't, but discourage it highly, more highly than normal, is they add a random seed to the end of every flag, and they make it a per client flag. So if I solve the challenge and RJ solves the challenge, we will get different flags. They will probably have the first couple of characters the same, like this part. But after that, they add a random seed to the end. They can do this because of how they host their challenges. It's actually, it's pretty cool. I think they associate it with your IP address or something, to make sure that the IP of the person doing the challenge is the same as the IP of the person submitting. Either way, that's likely why this isn't working. And if you do play Pico CTF, you might run into that. So if you are playing and your friend gets one flag and you get a different flag, but they both work, don't freak out. But anyway, next we'll be doing Log On, which is another kind of baby's first web challenge. Like I said, I'm actually not a web person. I think I've solved like 5 web challenges ever. Don't ask me questions about, well, you can ask me questions about web. No guarantees that I will know the answer to them. Pwn challenges? I got you. Someone please, someone has to take over my pwn, my precious pwn category. But anyway, so this challenge, again, web exploitation. The factory is hiding things from all of its users. Can you log in as log on and find out that they've been looking at? And then it gives us this link, which is right here. Oh god, what was that? Okay, someone made noise. Anyway. So it told us to log in as log on. And then that was the username. Well, I don't know the password. Let's just try password all lowercase. Alright. No flag for me. But it says success, I logged in, which is kind of interesting. Usually, if you give a random username and a random password, it won't log you in. That's interesting. I'm going to do inspect element again, because I know 5 things about web, and that's one of them. So if we look at the sort of source code for this, nothing stands out as being a flag. There's no like crazy like flag function or anything. So it doesn't look like we're just going to be able to do what we did last time and pull out the flag from the source code. Another thing about websites is that they can store cookies. So that will kind of save your different characteristics about the website. Say you logged into Amazon, it's going to save the fact that you logged in. So every time you open the tab, you don't have to log in again if you're in the same session. That's session cookies in essence. So we can go over here to application, and that will give you a lot of different information about the website. I honestly don't know what a lot of these mean. Google is your friend in this, of course. But one of those things is cookies. This is also all on Chrome. I'm a Chrome person. If you were to be doing this on Firefox or Safari, those are kind of your 2 other options. Edge is not great for it. If you're still running IE, talk to me after the meeting. I'm just kind of curious what led you to that point. But we can see that we have some cookies. So we have the username, which we set to log on. We have the password. I typed in password all lowercase. That's kind of my default. And we have this admin value, which is set to false. If we go back here, it doesn't say anything about kind of the password or anything. I honestly thought it said something about can you get admin. But basically, this is set to false. We can, oh no, what did I do? Cool. We can set this to log on, password. All right, there we go. When in doubt, refresh the site. But we can set this to true. So that didn't seem to do anything, but like I said 5 seconds ago, when in doubt, refresh the site, especially with web challenges. If you changed anything, it's not going to show up unless you refresh. But because we are now admin such true, we can see the flag, Pico CTF, the conspiracy lives, and then a bunch of random characters at the end because it's Pico CTF. And this one might work or it might not. Who knows? But yeah, any questions on any of those categories? Cool. Cool. Well, I'll take up less time and
Thank you.
Yeah, that was awesome. Thank you. Who's up next? I know there's the Wireshark one, and then I've got like 2 reversing ones.
I mean, up to you. I can do the Wireshark one if you.
Yeah, go for it.
Or wait, was somebody else going to do that?
You can do it if you want.
All right, give me just 1 sec to open it up. One sec, hold on, the sharing's not working. Wait, can y'all see the thing?
Yep, I can see it.
Cool. So this is the Wireshark challenge. Usually it's under the forensics category, and typically what these will do is you have to download this packet capture. So you'll click it and download it. You have to have a Wireshark installed on your computer in order to open these. There are other programs, but Wireshark's pretty good. So if we open it up, it takes a while to open. There we go. So Wireshark is it's a packet capture. So on the computer or a device on the network, something is listening to all the packets that are going through the network and recording them down in this list. The earliest ones are at the top, the later ones are at the bottom, and each packet is 1 row in the list. So, you know, for starters, you usually just scroll through it and see what's going on. We can see that the bulk of it is these blue UDP packets. UDP is user datagram protocol. So it's like basically just a stream of, you know, bytes. There's also a lot of these ARP packets. ARP is just a way to link IP addresses to MAC addresses. So chances are the ARP is just some background network activity. We don't really care about it. It's probably going to be the data in these UDP packets that's interesting. And down here we have some more unrelated stuff. A bunch of this looks like, you know, background network activity, like Internet Control Message Protocol, LLMNR. None of that should matter for our purposes because it's not like it's used to, you know, manage the network. It's not really used to transmit data. We're going to look at the ones that are actually data being sent back and forth. So in the hints on Pico, they say, hint 1, try using a tool like Wireshark. Hint 2, what are streams? So streams in Wireshark are kind of a way to view a whole bunch of related traffic. So for example, a TCP stream, TCP is what, Transmission Control Protocol. The idea is, say like you open a TCP connection to google.com, that's a TCP handshake. You send, an HTTP GET to get the Google homepage. Google responds with its HTML, and then that's it. The stream is ended. In Wireshark, you would be able to go, I believe, to analyze, follow, and follow TCP stream, and you could see that entire thing represented as one stream. For UDP, you'll click UDP stream instead. And there's an example of what one might look like. So you can see basically it found all the packets that are going from, in the case of UDP, it found all the packets that are going from this IP address to that destination, from this port to that port. And that's how it identifies like one continuous stream of UDP packets. Basically the packets that are related to each other in some sense. In this little, this window's too big. In this little thing at the bottom, you can sort of iterate through the streams until you find the relevant one. Problem is there's a lot of them. The bulk of them are, from these higher level protocols like, what was it? LLMNR. And so how do you find the one that you actually care about? Sometimes you can search. Let's see if find works. Oh, whoops. Okay, no packet contain that string in its info column. Packet bytes.
Is it a case-sensitive search?
It looks like it's not because it found a lowercase p. I'm wondering if maybe this packet is the one. Nope, that's Pico, Pico, Pico. All right. Oop. Okay, but coincidentally, it turned out we were close because the very next one is. All right, let me step back for a sec. So you have a list of all the, or you're able to iterate through all the streams that are found in this packet capture, all the sort of related sequences of UDP packets that have been found. So you can step through them using this thing at the bottom. And if we just start at 0, which is the beginning, it's not 0, it's not 1, it's not 2. If I keep going to number 6, well, there you go. You can kind of tell that's the flag because they all have that format. And if I copy it, that should be it. Okay, yeah, so that was it. How would we actually find that without knowing it's stream number 6? Probably the find tool would have been good if I just kept going with it. Or not. Yeah, the tricky thing is it looks like it was split up among multiple frames, so it can't find the Pico string.
Follow stream, maybe?
Yeah, that's what I was doing. It's just how would we know it was in that stream without just iterating all of them? I mean, yeah, ultimately, just following the stream and sort of brute forcing your way through it by, if it's a reasonable amount, you can just scroll your way through them until you see one that looks like a flag. Not a horrible idea. But Control F can be your friend too. Yeah. I guess, RJ, should I also do the one with the TLS decryption key, or?
Yeah, we've got time.
All right, sure, I guess.
The two I'm demoing are going to be short, so go for it.
Okay. So another one that's really common is so there's like a TLS decryption challenge. Is it SSL or TLS? It's TLS. So TLS is the technology, I think, behind HTTPS. So when you connect to a website over HTTPS, it'll use TLS to basically encrypt the packets so that somebody like Wireshark, somebody sitting on the network and viewing all the packets, won't be able to tell what's inside them because it's encrypted. The tricky thing is you can configure your browser to save a log of those TLS keys. So for example, in a challenge, they might give you a file like this alongside the packet capture, which has basically a SSL TLS secrets log file. So these are like they're not the decryption keys, I guess, they're the random nonces, I'm assuming, which are used to set up the TLS encryption. So if we import these into Wireshark, we'll be able to decrypt. So I downloaded them here. We'll be able to decrypt the packet capture. So I'll just open up the PCAP. Again, it'll take a little while. There we go. So this packet capture has a lot of stuff in it, but the fact that they gave us an SSL secrets log pretty much immediately tells you it's probably going to be an SSL decryption challenge. And you can see all these TLS v1.2 packets like application data. So this application data packet would contain some sort of HTTP message inside it, but because it's encrypted, we see HTTP over TLS. Because it's encrypted, it's just a bunch of garbage. We can't tell what it is. So you can solve that by, I believe, right-clicking it, going to protocol preferences, and which one is it? I believe it's pre-master secret log file name. I'll go with that one, yeah.
It sounds familiar.
Yeah.
Oh yeah, that looks right.
Yeah.
I remember staring at the screen at Kaizen.
That'll open your preferences window. You can also get to here by going edit preferences and then finding the protocol SSL in this gigantic list. There we go. So yeah, you're just going to want to enter the thing. Oops. And yep, once it grabs it, it'll rescan the PCAP file, and this time as it goes along, it'll decrypt the TLS packets using that secret key we provided. So now the packet that I was on before is no longer, it's no longer says application data. Now you can see it's plain text HTTP. And crap, I totally forgot how to actually get further from here. Could try find again. Oh, okay, that worked. So we just did edit. So right, all this stuff has been decrypted, so it's now visible in plain text. So we just went edit, find packet, set it to packet bytes and string, and then type, some thing that is going to be there, like Dawg CTF, and it found this packet for us. So at some point it said Dawg CTF extracting from PCAPs is fun. I'm about to say that should be it. I'm actually not convinced. Wait, RJ, do you remember if this was like a multiple question?
It might have been, but I think since we've shown them how to do this one, it's fine.
I think so too. Yeah, because this isn't.
I'm pretty sure this is the answer for actually decrypting it, and then there were later things after you decrypted it that were like get statistics about the file, like how many in a certain protocol. So I think that was the answer.
Gotcha. Okay, cool. While you mentioned that, I will leave on one more note. Wireshark does have like a whole statistics thing. So a common question is like, it's like how many HTTP requests were made to google.com. So you just go statistics, statistics, HTTP requests, and there you go. It counts them. Yeah. But yeah, that should be all.
Thanks, Nicola. I always forget all about Wireshark, so it's good to refresh on that. All right, so it looks like I've got the last two. I'm going to start streaming. They should go by pretty quickly. Also, while I'm setting up, I'll just give a quick announcement. Remember that we've got a CTF this weekend targeted for beginners. It's the Boiler CTF. So if you're interested in signing up for that one, we'll be competing pretty much all weekend, but we're mostly going to be getting together on Saturday. And there's information about that in the, I think it's called the competition teams channel in Discord, and we also have it in the CTF channel in Slack. Okay. So the last two I was going to do were a couple of very simple reversing challenges. Unfortunately, we can't really get into these too much because, like the pwn challenges, it often takes a little bit of assembly. But there are some tools that you'll see for some of the basic reversing challenges. So we'll be starting with this one. So this is actually under the forensics one, but it uses a command that's very, very commonly used in reversing. So it's going to have us download this image. I want to download it, not... Oh, I did download it, okay. So let's go look at that image. What? Oh. What? Where did I put that? All right, well, we're going to move this to my documents. All right. All right, so we have this image. Often reversing will have you look at some kind of executable binary file, but I'll be showing you the same tools for looking at this as you would with any other. So first, like if you were to print out this image, you just get a bunch of like garbage. So like, yeah, so it even warns you it's probably a binary file. And yeah, you can see there's not a lot of informative stuff in here. However, there might be some information encoded into it somehow that takes the form of a readable string, like the flag. So when I say string, I mean a sequence of printable characters. Oh, highlighting doesn't work. But you'll notice that where I'm moving my cursor down here, there's a long sequence of a bunch of printable characters all in a row. It's not separated by white space or any kind of unprintable characters, which are kind of shown in white right here, as just like whatever the hexadecimal byte is being represented. And to see these strings, you just run the strings command on Linux. I think we've mentioned it during our second meeting. But there's a strings command. I'm just going to say strings on garden.jpg, and we'll print them all out. And wouldn't you know it, we get a flag. So I'll submit the flag, but the first thing I want to talk about is there's a couple handy things for the strings command. The first thing is you notice we got a bunch of garbage here. That was just kind of like short sequences of random characters. And so I believe strings is by default 4 or more, but you can use the -n flag to say only show me sequences of a certain number of characters or more. And usually I'll do 8 so that you get more meaningful strings. You'll see there's still a bunch of random ones. But sometimes when you're looking at like executable files, it will limit you to only more useful stuff. But when in doubt, run strings first. And you may just find some information encoded into that file. So if I were to submit this, and go back to my browser, should give us the flag. Yep, all right, so we got it. And what was the other challenge I wanted to do? Ah, okay. Was called white pages. So it gave me this text file. I just downloaded it. So I'm going to go back to here. Actually, I think I have to copy it. Oh, it isn't. Oh, all right, now it's in downloads. That doesn't make sense. Right. All right, so we have this text file. Let's just read the text file and see what's in it. It actually appears empty. Like if I just cat white pages, there's a bunch of like blank text. So that's unusual. And again, strings won't help here either because there's nothing printable. So we shouldn't get any strings. I guess actually it did give us the strings of white space, but that doesn't help. So one other handy command to know about is hex dump. It'll print out the actual bytes of a file encoded into hexadecimal, and then it'll also try to show you a column of what the characters are in a printable format. So I don't know what the flags stand for, but hex dump -capital C lowercase v prints it out in the format that I like. Okay, and then I'm going to pipe that to less so I can scroll through it. So here's at the top, it'll show you line by line. So there's going to be 16 bytes per line. Each of the columns has 8 bytes in it, or each of these is a single byte. So this is the first byte, second byte, and so on. And the column on the very left will show you where in the file you are. So these are bytes 0 through hex 16, or sorry, 0 through 15, because this is in hexadecimal. So these are 16 through 31, and so on. And then it's showing me like dots and spaces here in the output when it like tries to print them out. You'll actually notice that all of the bytes are either hex 20, which is ASCII for space, or 83. Actually, there's also E2. Huh. Okay. But it does appear to be some kind of binary encoding. So let's write a quick Python script. There is 20 and 83 in E2. All right, so we're going to do with open whitepages.txt as f. I want to read it. So this is just opening the file. We're just going to say data equals f.read. And then let's iterate through each character in that file. So we'll say for my char in data, print, and then we're going to convert that to, I guess, like an integer or something, just so that we can read it, right? And am I going too fast? Does anyone want me to like stop and explain anything? Going once, going twice. All right. So let's just see what this does. It's just going to give us a bunch of numbers all on different lines, I guess. Never mind. Oh, I have to like encode it. Is it data? Is it this? I always forget how to encode things in Python. Okay, yeah, it is. So it looks like everything is either a 128 in decimal, a 131 in decimal, or a 32 in decimal. Oh, wait, there's some other stuff. Huh. Okay, when I read about this challenge, it was not like that. Let's just kind of count to see how frequent each of those characters are. So we'll make like a dictionary that has counts in it. There's like a counter object you can use in Python, but I don't want to deal with that. So counts equals this dictionary. For my char in data if counts.get my char is none. So that means if we haven't seen that character before, we're going to make a new entry into the dictionary and just set it to 0. And then we'll increment the count for the current character by 1. So we're basically just going through and counting how many of each there are. And there's like a actual Python library for doing that cleanly, but I don't care. And let's just print out all the counts. Right, so we have, oh, interesting. This is not how I remember the challenge going. All right, so there's 803 of the 226. There's 803 of 128. There's 803 of 131, and 32 of 573. So I forget, because I thought there were only 2 main characters in there. I'm wondering if, oh, you know what? I think it's always E2 8083. Or sorry, I think it's always like, I think these always are going in a row. So let's see if this is like binary. So I guess it's all like groups of 3 followed by hex 20 is like 0. Let's try encoding it that way. And one thing we can do is we'll just replace all of the incidents of those 3 characters showing up with 1s, and then all instances of 20 showing up with 0. Oops, that was not it. So we'll say data equals data.replace, and then we want to replace E2 83 with, actually, I think that's zeros. We could try it each way. So let's try it with 1s first and see if that works, and otherwise we'll try it with 0s. And then we're going to also say data equals data.replace 20 with 0. So it seems to be some kind of like binary encoding where these are either 1 or 0, and these are either 1 or 0. And then we'll convert that to, and I think we have to like get rid of the spaces as well. So I'll get rid of the spaces. And then finally, we have to actually convert from 1s and 0s to binary. And I'm just going to shamefully steal this code. So it'll basically iterate for over sequences of 8 bits. So for I in range 0, length of the data, and I think you just skip by 8. And then we're going to print convert to char int, because we're doing this is like what we saw in Anna's demo. We're going to be converting from base 2 binary to ASCII. So this is how you do it without the RE stuff. It's ugly, and I think RE is better. We'll say data at I through I plus 8, which will get like a window of 8 bits at a time, and then we're going to skip every 8 characters. We are encoding it as binary. So this here is getting a sequence of 8 bits, converting it from binary to an integer, and then casting it to a character, and then printing it out. So let's see if that works. Okay, actually, I guess I don't encode it. Let's try that. Nope. All right, well, we're debugging. Okay. Oh, I'm stupid. All right, this needs to be a string. And I hope that'll work now. No, okay. So, let's see. I hate encodings in Python 3. Ah, okay. I think it's this. Nope. Okay. I should have been more prepared in the first place. I'll work this one out and send a solution to the channel. But other than the data encoding, it's basically taking ones and zeros from this file and encoding the flag in binary that way. So I'll send a solution to the Q&A channel. But are there any questions about that one? Also, does anyone who does know Python 3 encoding want to help me with that? I'll Google it in a bit, but I don't want to take up too much time because it's getting late. All right. So that was the last CTF challenge we had for the night. Are there any questions before we wrap the meeting up?
For reference, due to trying to make everything as clean as possible for the stream, I have forced everyone who's not in a board or equivalent role needs to have push to talk. So if you do want to say anything, you need to click the button to say it.
That's a good idea.